So, good evening, one and all. Welcome to this session of machine learning using SQL for your data in your data warehouse. Firstly, I would like to thank all of you who has joined on Sunday evenings. That means a lot. So, thank you so much. And secondly, I would like to thank our community partners, that is Pune Deep Learning Club, Bangalore Deep Learning Club, and Bang ML Group. So thanks a lot. We have partnered with communities, so their members can also join us and learn. So without wasting much of your time, um, here is Suman Devnath. Hi, Suman.
Hey, hi Karthik. Good evening.
Yeah, good evening, man. So thanks for joining us, Suman. And uh, would you please give you a brief introduction regarding today's topic and about
Sure,
yourself as well?
sure. Yeah. So, thanks everyone for joining in, and I really appreciate, as Karthik mentioned, in a Sunday evening, we'll try to wrap it up within 30-40 minutes. But what we are going to talk about is how you can make use of machine learning directly from your data warehouse. You don't have to know about data warehouse or SQL as such, but we'll just give you an intuition that what are the possibilities that are there, when you work with SQL with machine learning. So I'm very sure that you all are from machine learning background, so you know how to train, build, and deploy models. But today we are going to talk about a little bit different, that how machine learning can be done, and how customers use them who are not a machine learning expert from using SQL. So we are going to talk about a bit about that. And about myself, I'm based out of Bangalore. I work for AWS with the developer relations team. I've been working on predominantly on storage and protocol, like Fiber Channel, NVMe, and SCSI for last 10, 12 years before joining to AWS. And in AWS, I predominantly focus on storage and machine learning. And I just hope that you get some insights about this particular topic, which will make some. I mean, you will make some useful time in the Sunday evening. So, thanks for having me.
Thank you so much, Suman. Could you please share your screen?
Yeah. So please let me know if you are able to see my screen.
Okay.
Okay. I hope it's visible, right?
Yes, it is visible, Suman.
Okay. Cool.
Okay then.
All right. So what we are going to do now is I do have some slides, but I'll not go over all these boring slides. But just to set the context before we get into the console and show you what it is, how it works, I just thought to give you some pointers. Okay. So at any point in time, if you see that the screen is not visible or it's frozen, please put that in the chat so that Karthik can inform me, even myself, because I'm not able to see the other screen. So what we are going to talk about is how you can make use of machine learning using simple SQL query. Okay, so I assume that you may not be from a database background, or you may not be a database engineer. If you are, then nothing like it. This is the this is the most interesting session for machine learning if you are passionate about machine learning. But if you are a data scientist or a machine learning engineer, you can get some insights of how people use machine learning who are not familiar with machine learning. Okay, so if you look at it, we have generated a lot of data, right? So I still remember when I was in college 10, 12 years back, we did not have smartphones or tablets that rampantly. Like today, you have tablets, mobiles, and everywhere. Right? So the kind of data that is getting generated, not only using these consumer devices, but also devices like IoT sensors, cameras, and all of that, it's enormous, right? And if you see, there are a lot of companies are built using those data only, right? They have just make use of that data in a right way to make some business use case out of it. Now, when you look at all these data, they all are coming from different sources, right? So some might be coming from cameras, some might be coming from your mobile phone, and so on and so forth. So they all are having different sources of data. So now, when you do an analysis on that type of data, right, it's very difficult, right? Because you have to clean the data, and all different sources have different types of data coming in. So you have to spend a lot of time when you think about data analysis at scale. So we are not talking about a small set of data. We are talking about data at petabyte scale. Okay, so that is kind of the challenges that we have. One of the challenges that we have when we do data analysis at scale. Similarly, as you can assume for any system, the more you scale, the performance goes to the back seat, right? So that is also one of the problem with data analysis at scale. And obviously, things gets more and more complex. You come up with different tools to manage that, because when data scales, you talk to people that how to manage that, and then you again talk to people when it goes beyond a certain point, and everyone will suggest you different tools, right? Yeah, you come to me, I will suggest you something. You come to Karthik will suggest you something. So it basically becomes a mess over the period of time, right? And the last thing is, which is one of the most important thing, is the cost. So when you are dealing with data at a very huge scale, you cannot predict the cost, right? If your manager or your management ask for, how much money you would need for next 1 year, you may not predict, right? So you can extrapolate based on your history data, but you may not predict it in a better way, right? So all these challenges, we thought about it at Amazon, and that's how the team has built this service called Amazon Redshift. So this is not a talk about Amazon Redshift, but we are going to talk about Amazon Redshift ML. So that's why this is just a brief 10,000 feet overview of Redshift. So Redshift is one of our managed service, which you can use for data warehousing. Okay, and it can do a lot of things apart from just data warehousing. You can do analytics. You can source your data from some other source like S3, which is our object-based storage, and you can even take that data from S3 to do some different analysis in different pipeline. You can connect it with other services within AWS, just like any other service, right? And one of the most important thing is, you can predict the cost. Okay, and this is much less expensive than other data warehouse services that we have. Although it's not that very cheap, right? You will not get it in under your free tier, but you get the idea, right? It's one of the service that we have for data warehouse. Now, when you talk about data warehouse, there are different users who use any data warehouse. So there are database engineer or database developers or data engineers, which are kind of the first line of people who uses this service, and there are other people like data analyst or data scientist who wants to make use of the same data but in a different perspective, right? So think about it like this. Let's say you are a data analyst and you have a data of all your customers, and you are working in a banking domain. So as a data analyst, you may be interested to know how many customers you have in, let's say, in Bangalore, how many customers you have in let's say Mumbai, and you want to do some analysis. What is the age group that they belong to, so that you can help the team to take some decision based on those data. Like maybe a promotion you need to do to, let's say, people who are your customers who are less than 30 years and in Mumbai, right? So you might have to do some different promotion in Bangalore. So these are the use cases that a data analyst might look into. Similarly, for data scientists, they might look into something else. So they might try to see the same data, but they want to make a model which can predict, let's say, a fraud transaction, right? So, or they might want to predict something like churn prediction, right? So how many customers of yours is likely to close their account in next 6 months? So these are the questions that the data scientist might have to answer using the same data. So all these different professionals like data scientists, data analysts, BI professionals, admins, all of them, right? They all use the same data warehouse. So you can think about the data warehouse here, that is maybe a Redshift in this case, and all of these users try to do different things, right? So how you can do all of that. So this is where our customers told us that why can't we use machine learning on this data warehouse directly, not like pulling the data to some different source and then hire one machine learning engineer, tell them what to do and then solve the problem in a separate zone, right? Why can't we use machine learning on our data warehouse itself, right? So you might think, why we need machine learning. So there are different different arguments to that, right? As we have discussed all the problems, we can use machine learning to improve our operational excellence, right? Or operational business operation, right? Because it will be more fast to come to a conclusion, and then we can make better decisions, right? Because you don't have to send the data to a different place from your data warehouse to the data science team, and do all of that and then come back, right? So it's a quite a long process. So this is where ML in data warehouse come in, right? So these are the few of the use cases which you can think of that we can do, like customer churn prediction, predict if a sales lead will close or not, right? These are the standard classical machine learning problems, right? It's kind of a binary classification problem, right? Churn prediction, or let's say sales lead will close or not. These all have two outcomes, right? Yes, no kind of thing. Then you can also have a price to revenue prediction. This is kind of a regression problem, right? So we can even try to do that. Then we can have fraud detection, as we were discussing a while back, and we will see that in the demo as well. So all of these are few of the use cases that you can think of on your data warehouse. Now, if you think about machine learning, you will see that since you are a data scientist, most of you are working around data science or data science machine learning, you would know that the whole process of this machine learning workflow is quite complex, right? So it's not like anyone can do. If I'm not an expert, I may not be able to do the whole thing. Forget about the data science knowledge or education that is needed. Like when I'm saying data science knowledge or education, I mean knowing the algorithms, knowing the statistics and all of that, right? But forget about all of that. Even if you assume that you know that, the whole process pipeline itself is quite complex, right? Starting from preparing the data, to build the data, then train and tune, and then finally deploy that, right? So this whole cycle itself is quite complex. And although with the help of cloud and AWS and even other vendors, things have streamlined a bit, but still you need a lot of education and training, right, to do that. And this is where Redshift ML come into picture, right? So what Redshift ML does is basically you have your data in your data warehouse, right? So that is the prerequisite. So you should have your data in your Redshift ML cluster, right? If it is not there in your Redshift ML cluster, you might have to pull that data from that source, right? But assume that your data warehouse is using Amazon Redshift and you have all of your data here, right? Now, what you can do with Redshift ML is you can use a simple SQL query called create a model, as you can see here, right? Create model. If I can mark it, yeah. So you just have to use this simple command called create model, and you have to share what is the input data, because when you in machine learning, when we train a model, or when you develop a model, what you do, you give the training data set and the test data set, right? So similarly, when you run this create model command, all you have to do is you have to point the data set, what is the input data, and you would know that the input data is in your database, which is stored in Redshift ML, right? And when you do this, create model, you can define different parameters, right? If you are a data scientist, you can even define what algorithm to use. You can even define few of the hyperparameters, all in the same SQL query. And let's say you are not a data scientist or a machine learning engineer. You are maybe a database engineer or an SQL engineer. You can just let it go. Like simply, you can use select model, and Amazon will automatically, will read through your data, and it will try to use the right algorithm for your problem. Okay, but the idea is you will just have to do you will just have to run this create model command. Okay, and then what happens under the hood is it will fetch all the data. It will take all of your data from here, okay, to S3, which is our object based storage. And then this S3 data will be used to train a model. And who will train the model, and where the training will happen? Training will happen in Amazon SageMaker, which is our machine learning service, or platform rather, for all your machine learning tasks, right? Where you can train, build, and deploy your models. But here, as an end user, you are the user here, right? As an end user, you have no clue about SageMaker, right? All you are doing is you are running this create model command. Okay, so once you run this create model command, as I was saying, the data will be copied from your Redshift cluster to Amazon S3, and then it will be used by SageMaker to train the model. And which algorithm it will use, depending on how you have executed this command. If you have specified the algorithm, it will use that algorithm. Or if you have not specified the algorithm, it will use AutoML, and it will pick the right algorithm. And then once the training is done, it will deploy that model, and it will deploy the model on SageMaker itself. And at the end, once the deployment is done, it will return a function. Okay, it will return a function which you can use to do the prediction. And this function would be nothing but an SQL defined function. Okay, and we are going to see that in our demo. And then you can use that function to do the prediction. That's all. So all of these, like interaction with Redshift ML to S3 to Amazon SageMaker, all of these three things, right? Redshift, let me just erase this. All these three interaction between Redshift ML, SageMaker, and S3 I have not shown here, but you can think of this, because it is going to copy the data from S3. So all these three interaction, right? You don't have to worry about all of that, right? All you are doing is you're running this create model command. That's all. Okay. So this is the beauty of Redshift ML. And we are going to see that in the demo, which will help you to, comprehend all of that. Now, one of the other thing is, before we jump into the demo, is from the cost standpoint, how much money it is needed. Sorry, let me just. Yeah. So how much money it is needed for you to train a model? So if you look at it, training is expensive, as we all know. We need maybe you may need to have a very high intensive compute or GPU even, right? So we know that training is expensive. But at long run, you will see that for any organization, prediction takes most of your cost, because you will not train every day, right? Most of the time you will be doing prediction. So with Redshift ML, what happens is all your prediction comes with no extra cost, so you don't have to worry about the prediction cost. So that there you save a lot of money, right? So it's only the only time that you pay for is during that training time. Okay. So now this is how it works. So I guess it would be good if I go to the console and show all of this in action. Okay, so I'll not go over this PPT. If you are interested, you can, I can share this PPT. You can go over that, but let's go to the console and see it in action. So before we get into the console, maybe Karthik can share this URL. So whatever we are going to discuss now, it's all mentioned in this blog. So there are two parts to this. So you can go over this, at your own pace. So what I've shown here is we have 3 demos to show you. So maybe today I'll show you 2 demos. It's all similar, just a different perspective. Okay, there are different problem statements that we have taken. But in this blog, since this is part 1. In this part 1, we are going to take one example, keeping in mind that you are a database administrator or a database engineer, right? And part two will have two other demos. One demo is with a view that you are a data analyst, and another view is, let's say, you are a data scientist. Okay, so why we are doing these three demos with three different users in mind? Because we want to show you that what are the different options that you get when you run that create model command, right? So as I mentioned, if you are a database engineer, you may not know much about data science, right? So you will use AutoML. But let's say you are a data scientist, so you may know a lot of things around the algorithms. So you can specify those algorithms, you can specify the hyperparameters and all of that. So that's why we have three examples to show you how all of this works. Okay, so let's go to our console and show it to you. So this is the AWS console. Okay, so we don't have to come to AWS console for this, but I just want to show you that I already have created a Redshift cluster. Okay, if I click here, I've already opened it in a different tab. So creating a Redshift cluster is very easy. Now, if you follow that blog, you can get all the details. But you just click on create cluster, and it will create a Redshift cluster for you. Okay. So I'm not going over this creating cluster and all of that. But once you create this cluster, you can click on this cluster name, and then you will have some endpoint. So we have to connect this, because I'm not going to use the editor here, which comes in the UI itself, because this is something which is good for playing around or doing some hello world kind of querying. But for real world use case, you will connect it through some SQL connector, right? So we are going to use a data grip tool for that. So all I have done is I've used this JDBC connector, and I have used this tool to connect. Okay, so this is data grip. So data grip is just an SQL client. And I use this to connect to anything, any database, basically, even Aurora or Redshift or anything. I like all the PyCharm products, so I'm a little biased to that. All right, so if you see here, if I right click on this, and I guess there should be some property. Yeah, you see the property. This is my Redshift cluster, right? So if you see, this is my Redshift cluster which I have connected, and if you see here, this is the same Redshift cluster, right? MIG, if you see here, and this is the same one, MIG, right? Just to give you a intuition that we are connected to the same cluster. All right, so now all these demos, we have three demos, as I mentioned. If you can see it here, demo 1, then there is demo 2, and then there is demo 3. All of this are there in this GitHub. So if you come to this demos, you will find that three SQL files. Okay, so you can just go over them. So now we are going to go over demo 1, and then demo 2 or demo 3. You can do it at your own time. So let's get into that. So what we have to do is first, once you have that cluster, it doesn't have any data, right? So you need to first create a schema. I'm not going to create that because I already have, but this is where I'm creating this schema. And but then we have to create a table, right? So ideally, since this is a demo, we have to stimulate, load the data. But ideally, your data will be always there, in your data warehouse, right? So in that case, you don't have to create tables and all of that. It will be always there. But for this problem, we have taken a free data. I mean, free in the sense it's an open source data where you will have all these information about customers for a bank. Okay, and all you have to predict is whether a customer will open an account or not. Okay, so it's kind of a binary classification based on all this information. Okay, and this data, what I have done is I have saved all this data in CSV. Okay, and this CSV is saved in my S3 bucket. Okay, so here what I'm doing is first I'm creating a table. Okay, and in this table we are giving all those field names or the parameters, right? And these parameters or column names should be exactly same as the column names in this CSV file, right? So that when you load the data, it matches. Okay, so this is the training data. That means I should have the class label for this as well, and this is the class label y. Okay, it's a very horrible way to name the class label, but this is the class label which says that whether a customer has opened an account or not. Okay, so just remember this, that during the training period we are going to use this whole data set, and we will say that y column contains the class label. Okay, so once we have created this table, and the table name is client details, and this is under the schema, that's why it's demo ml dot client details. What we are doing is we are loading that data, and when you try it, if you want to try it, if you come here and click on dataset, you will have that bank additional full.csv file. So you can save this in your S3 bucket, and you can load it. So in that case, you just have to give your own S3 bucket name. That's all. Okay. So once you load this data, I'm not loading it because the data is already loaded. After that, your database will have all the data, right? Now I'm creating another table, and this table is for inference. Okay, that means this is the table where I'll be using for testing. Okay, so same again, it has the same set of columns, and it also has y. Okay, that means it also has the class label. And why we have for inference data we have class labels? It's just for checking, because we want to check whether our prediction is correct or not, right? So that's why we have this a y column here as well. But in this case, we are using a different file called bank additional inference. Okay, previously it was bank additional full. Okay, and both these files are there in this GitHub repo. Okay, so we are just copying the data from our S3 bucket to this data warehouse. And if you see here, we are also giving some IAM role, and this IAM role we have to create. I have not shown you how to create, but it's pretty simple. In the blog post, it is mentioned, how you can create this IAM role. But what is important to know is why we are needing this. The reason that we need this IAM role is to interact with any service, within AWS, you need some roles and permissions, to access, right? So here we are trying to copy data from S3 to Redshift cluster. That means we should have that permission granted, right? And this is where we grant all those permissions. Okay, so that's why, and you have to create this beforehand, and in the SQL command itself, you need to use it. Okay. So that's about it. Now, once this is done, then you can go ahead and run the create model, right? But what we are doing here is next couple of lines, as you can see, all these commands. These are just to show you how you can control, the a creation of model. So imagine that, let's say, you want only a set of people to run the create model commands, right? In that case, you have to have a different group, right? So that you can manage your access nicely. So this is where we are. This is what we are doing it here. So we are creating one database, a DB dev group, which comprises of all the database engineers. Similarly, we are creating another group called data science group, which comprises of all the data scientists in your team. If you don't have any data scientists, that's completely fine. You may have just one group, maybe dev, right? But the idea is, you can create different groups. You can create different users, and you can add them in a different group, right? So in these 4 lines, we are just creating 2 groups and 2 different users for 2 different groups. Okay, and then why we are doing all of this? Because we have to grant permissions, accordingly, right? So that's where the next section is about, where you can define which group can do what, right? So if you see here, we want to restrict create model commands only to data science group. So that's what we are granting create model to the data science group. That means if you have logged in as a database engineer, like a DB dev user, you won't be able to run that create model command. It will fail, saying that you don't have enough permission. So this is what all the granting of permission that we are doing here. Like we are saying, you can create, you can use usage on schema for this particular schema for all the users for data science group, right? So this is very SQL specific, nothing to do with Redshift ML, but just want to give you an intuition that how you can segregate access control to different set of users. Okay, so now we are done with everything. So all we have to do is now we have to set the user who will create this model. So that is what we are doing it here. We are setting the authorization to data science user, and this is the user which we have created here. If you see in line number 68, right? So we are setting this user now. And then since I was doing it for demo, I was running it multiple times. That's why I just have this drop command. If there is any model exist, just drop it so that the creation doesn't fail, right? So you can ignore this. This is just because I was doing it for demo. So this is the ultimate function. Okay, so the function looks like this. It's very simple. It's just create model, and then you have to give a function name. And I'll talk about why we need this, why we need to give this function name. So the syntax is very simple: create model, and then the function name from. So this is the place where you put all your training data. Okay, and if you see, it has all those columns in your database. Right, so you can select a set of columns for your input data, but in this example, we have given all. Right, so you can even say select star. That is also fine, but this is the place where you give all your training data. Okay, and as I mentioned, since it's a training and it's a supervised training, you need to tell the model that what is your class label, right? And that is what you give using this target parameter. So target space the column name. So let's say in this case, I know that the column name is Y. So that's why it is Y. But let's say for other problem, the column name might be month. So in that case, you will just type month here, right? You get the idea. So you give the input data, and then you define what is the class label. And then you give the function name. So there is the same function name which we have given here, right? And why we need this function name? Because this is the actual function, user-defined function, which will have the endpoint. Okay, so once we execute this command, what Redshift is going to do is it is going to copy all the data to S3. Okay, and then it is going to use Amazon SageMaker to train your model. And then once SageMaker trains that model, it will deploy that model. And once the deployment is done, it will be available to Redshift as a function. And later on, when you do the prediction, you will use this function, and which we are going to see in the next statement. Okay, so that's why we need this function name. And similarly, we need to define the IAM role because again, in this case, SageMaker is going to access S3. Redshift is going to access S3 and SageMaker. So you should have that role. So this is the same role which we have created before, which we have used in the copy command as well. And we just have to give the same role. And in this case, as I mentioned, your Redshift ML is going to talk to S3, right? Because it is going to copy the data to S3, and then that data will be used by Amazon SageMaker. So you need to define the S3 bucket name. So this is the bucket name. You can give any bucket name of your choice, and you can set it here in the settings section. And you can also define the max runtime. So by default, I guess it is 30 minutes. That means it will train till 30 minutes and then it will stop. Okay, but you can define that. So the idea is I just want to show you that you can define all of these parameters. So if you look at this, we have given the input data. We have we have mentioned the target and we have given the function name. That's all, right? We have not mentioned what type of model it should use, whether it's a supervised, whether it's a regression problem or a binary classification problem. We are not giving any information, right? That means we are telling AWS or Amazon SageMaker that you use AutoML and pick up the right algorithm for me. Okay, so I'm not going to run this because I've already created this model. But once you run this command, you can run this select star from STV ML model info. So let me just run this. I'll show it to you how it looks like. Because the create model command is an asynchronous command. That means you will get the command output before the model training is done. Okay, so just to check the status of your model, you need to run this command. Okay, so let's see. I just hope it's connected. Should not take that much of time. Okay, so I'm not very sure why it is taking so much of time. Just give me a moment. But once this, you see this model, that the model is up and running and it's available, and that means the training is done, you can use the show model command. And in this show model command, it will show all the models. So in my case, I have 3 different models created. So you should be able to see 3 models, I guess. Okay, so let me see if... just give me a moment. Okay, this is up and running. So I've used tunneling. So basically, this Redshift cluster, if you come to permission properties, the public access is disabled, right? Because that means you cannot just directly connect. You have to connect through the EC2 instance. Okay, so that's why. But let me just check it once more. Okay, it says SH timeout. Okay, so give me a moment. Let me just try to enable public access. Okay, let's wait for some time. It is modifying the cluster. I'm not very sure why it is happening. Okay, so while this is running, I want to show you how you can do the prediction. Okay, so once this model is ready, you will see the status, and I'm going to show you that once I connect to this cluster. But once that is done, you can do prediction, right? So for prediction, the prediction can be done by a database engineer, may not be the data scientist, right? So that's why we have this set authorization command, where you are again changing it from data science user to DB dev user, right? And once that is done, you can do prediction. Now, if you remember, when we created this model, we have created this function, right? And we mentioned that you are going to use this function for prediction. So we are going to do exactly that now. So in this command, we are checking the accuracy of the model. You remember that in the inference table, we have that Y column, right? And why we had that Y column? Because we wanted to check whether the prediction is correct or not, right? So this statement is for checking the model accuracy. And how we are doing that? we are saying with inference data as, and this is a nested SQL statement. If you are from database background, these statements might be familiar to you. But interesting part is this: you are doing the inference using this function model bank marketing, right? This is the function that we have created. And if you see here, we are giving all the input data. And see this, we are not providing the class label y here, right? Because we are doing an inference. We don't want to give the class label, right? So whatever output that it gives, we are saving it as predicted. Okay, so all we have to do is now you have to check whether this predicted data or whatever the model is returning, whether it is same as actual or not, right? So actual is nothing but your y label, right? And y label, I'm terming it as actual. So that is what we are checking in this case statement. Okay, and then we are just summing it up, how many predictions are correct and how many predictions are wrong, right? And we are just printing it. Okay, that's all we are doing. So that's how you can do prediction. So this is for accuracy. Similarly, at later point in time, if you want to do a prediction of any of your data, you just have to call that function and you give all your input data, right? This is all your input data, right? And you can just predict for everyone, right? Or for all the data in your database, not one by one. And all this prediction are free of charge, right? Because your model is, you're not inferencing to the SageMaker endpoint model directly, right? So you are doing it through Redshift, and Redshift is taking care of getting your data from doing that inference from your data warehouse directly on your endpoint. Okay, which is at the end of the day, in the back end, it's nothing but a SageMaker endpoint. Okay, so let me try to connect to the cluster. If the cluster is ready, I guess the cluster is ready. Let me try to connect. Okay. Okay, let me see. Just give you a moment. See that. In the meantime, no. If you have any questions, please let me know. I don't think you have any questions. Okay, if you have any questions, please let me know. I don't see any questions as of now. So that's fine. Okay, but while I was doing this, I kind of guessed why it is not working, because I actually disconnected the tunnel, I guess, some time back for something. But that's fine. So we'll see if it works. If it doesn't work, then let me see why it is. Let's try to connect. So let me try to run this. Sure, if we can do this here. Let's try to run it here. While this is running, let's copy the same command. So let's see the output. Okay, so here it's working. So I'll check, why in this client it is not working later on. But I guess it was something to do. I'll just give it a last try for. I think it has some problem. Okay. So we can leave that. We will run it in the console. I'll just copy the command from here to there. Okay. So if you see here, we are just copying this and just to check the status of the models. So if you see here, it says that the model is ready. But let's say you are running this while the training is going on, right? So you will see that the model is not ready, and you will see a comment as the SageMaker training is going on. Okay, so as you can see, we have three different models because I have three demos and I've already trained those. But this is the command that we have executed, right, for function model banking, right? Bank marketing, right? This is the model. So that means the model is ready. So the next thing that you can do is you can again run show model, but this is going to do the same. It is going to show you the same models that it has, all these three models. Yes. Oh, don't know why it is. Okay, all these three models, as we can see. So the next thing is what we can do is, okay, I guess I have pasted it wrong. No, so let's start from, oh, okay, yeah, I pasted it wrong. Okay, so the next thing is we can do some prediction, right? So this is the accuracy, right? So let's copy this whole command and run it here. It might take a little bit of time because this we are doing for the entire table, and as you can see here, it says that the accuracy is 89%, right? So that's pretty okay because we have not done any tuning or anything, right? So now finally we can do the prediction. So here it will predict yes or no, but we are just naming it, framing it in a nice readable format. Okay, so let me run this so that you know what I mean. Okay, so let's run this. And if you scroll down, and you will see that it says that it has already, because at the end of the day, this is about the problem, if you remember, is to predict whether a user will do a term deposit or not, right? So you can see that the number of count is for yes is around 800, and no term deposit is almost more than 3,000. That means you can use this data to tell your team, maybe your marketing team, that hey, I don't see that our customers are going to open a term deposit, so you may like to do a some marketing around that, or send some promo or some promotional offer, something like that. Okay, so this is how you can do all of this. Now, this is very good. It's working fine. But I just want to show you another demo. Again, these are the demos which are there in the GitHub. You can play it around. But I just want to show you only the difference in the create model command. Okay, so this is a problem where the data set is different. So here we are taking a data set of different steels, okay, and there can be different faults in a particular steel, okay. And in this problem, I guess there are 7 different types of problems that of faults the steel can have, okay. So the model should predict the type of fault that every steel is having. Okay, so it's kind of a multi-classification model. Okay, so now imagine that you are a data analyst and you are not a database engineer. So that means you have a little bit better understanding of machine learning. So in this case, you are again, creating the model using this create model command. You are giving all the input data. I'm not, talking about the first few steps where you create the table, load the data, and all of that. It's all same. The only difference is here you are not only mentioning the target. That means you have to mention that, right, because that's a class label. But here you are explicitly mentioning what is the problem type. So the problem type is multi-classification, right? So that's what you have to mention, multi-class classification. And you can even define the objective function. So we know that, right, as a machine learning engineer, there are different types of objective function, all right? Like accuracy is one of them. Then we have F1 score and so on and so forth. So here you can mention that. And then you can again define the S3 bucket and runtime. Okay. And then you can do some inference as well. So inference is pretty similar, just like a previous example. But all I wanted to show you is you get a flexibility to define different parameters. It's not like you have to just say auto ML on or autopilot on, and a SageMaker will do automatically, right? So that is always there, but you have a full control on creating the model, right? So similarly, I have another example called demo 3. And here, if you scroll down, I forgot about the problem statement. I guess it was from Adlon test data. So you can check this out. I've mentioned that in the data in the blog, but for you, you don't have to worry about that data set at this point. But I want to show you that what are the different things that you can do. Right. So again, for this create model command, you are saying auto off. That means you are telling SageMaker that, hey, I am going to tell you how to train the model. You do not suggest me. Okay, that's what you are saying. And you are defining the model type. So you are defining that please train this using XGBoost. You are defining the objective function as square error. Then you can define the hyperparameters as well. And similarly, at last, you have to define the S3 bucket, right? So this is kind of a data scientist would do typically, right? Who knows about the data, who knows the algorithm and all of that. And then you can simply, run the inference just like, any other problem, right? So that's all about Redshift ML. So this is the only command which you have to run to create a model. Okay, and you don't have to deploy it because it will automatically get deployed. And then the way that you can do the inference is using this ML function, or sorry, SQL function, right? And this is the same function which you define while creating this model. Okay, so that's all about it. If you want to know more about this, you can go through the blog. Even the part 2 of this blog will contain these 2 examples. I think example 3, I guess, if I'm not wrong. Yeah. So this is the open data source that we have from UCI repository, and it has 7 features. Okay, and you can scroll down. This is exactly what we have seen a while back. You can define the model type, objective function, and all of that. And you can even do show model. I guess the last thing that I can show you is the show model command, because when you do the training, you don't know which model you have it has created, what is the accuracy and all of that, right? So let me just run that command and show you how you can get the details about the model in the console itself. So here we are just seeing the model details of this particular function. Okay, and if you come down, scroll down, you will see that the model is ready. The objective function is RMSE. It's 78%, and then it also gives you some different details, like what are the features that you have used for the query. Okay, so all the details you can get it here. So that's about it. And similarly, you can do some inference, and you can see, how the model is doing inference, and all of this is happening without you going to SageMaker, right? All using SQL, and this is happening for all of your data, right? It's not happening for one data at a time. It's happening in batches, so you don't have to worry about saving that data and loading it back to your data warehouse, right? It's already there. All you have to do is you have to run the SQL query in a way that it will do the inference and it will save that data back to your data warehouse. Okay, so that's about it. Feel free to explore this whenever you get some time. And if you have any queries or questions, you can comment in on this blog itself, or you can ping me on LinkedIn, or wherever you are, you feel like, and I'll be more than happy to help you. So that's about it. Let me just stop my screen. So that's all. Karthik, I think Karthik, you are on mute, and I see
Yeah.
there is.
Yeah, there are some questions.
Yeah,
I'll
what are the
highlight.
required package or extensions for the SQL part? Yeah, good question, Anish. So there is absolutely no need for any extension or anything of that sort. So all you have to do is you just have to connect to your database client, so SQL client rather. So I have used data grip, which did not work because I messed it up. I guess I did not do the tunneling, but that's nothing to do with the SQL part. So you can use any query editor to connect your database, right? So there is nothing specific that you need to connect to Redshift.
Here's the next question, Suman.
Yeah. So in the first copy command, what data does CSV has? Is the CSV exports the whole data that we have? Yes, that's correct. So that CSV file contains the all the data. So let me just show it to you maybe quickly. Let me just share my screen again, and let's see. Since you have asked, let's go to this. Okay, I already have it in my GitHub, I guess, right? So let me just show it to you what this data set is. Okay, so this is the CSV file, and if I just download it, you will see that this data, contains the whole data, right? So all these columns are this very small. Let me just zoom a little bit. So this all are comma separated values, and if you see here, if you just read this selected line, you will see that these are all parameters, and the last one is the Y class label, which can be yes or no, if you remember, right? Because yes means it will they will open a term deposit, no means it will not open a term deposit, right? So this is the whole data that we have in that CSV, and what happens is it just loads that data from S3 to your Redshift cluster.
All right. Thank you so much, Suman, for simplifying these terms for us and joining on a Sunday evening as well. And I would also like to thank all of you who joined again this Sunday evening. Thanks a ton. And thanks for joining, guys. That's pretty much it.
Sure.
Thank you.
Thank
Thanks,
you.
Suman. Thanks, everyone.
Thanks, everyone. Thanks for your time. Yeah. Bye. Take care.
Bye. Stay safe, everyone. Bye.